Hi, I'm Jeff Womelsdorf, Vice President of Product Development with Novaspace. Thanks for joining us on today's live stream. Today we're joined by Monica Azema, who's a longtime friend and collaborator of Novaspace. Today she's going to be discussing her new position in the space industry. So previously she was an automation engineer here in the United States. We met her at a few of the different space conferences that go on here in the States, but recently, she has returned to Spain and found a new position in the space industry, and she's doing some very cool and exciting stuff when it comes to composites. So, Monica, for the folks that haven't met you on our previous live streams, would you mind giving a brief introduction of yourself?
Yeah. Hi, Jeff. So my name is Monica Azema, as Jeff introduced me. I'm an aerospace engineer. I was working as an automation engineer back in Colorado in the States. And now I moved back to Spain, and I'm working in the space industry as a space business development. And I had the opportunity to do the Nova Space course, the Space Professional Certification. And this definitely helped me to go back to the space industry after working in manufacturing for a while.
Very cool. Thanks, Monica. So yeah, the company that you've recently started working for in Spain is called Compoxi. I was wondering if you could tell us a little bit about what Compoxi does.
Definitely. So Compoxi has more than 10 years of expertise developing and manufacturing advanced composite parts and composite metal assemblies. Compoxi offers turnkey product development and can offer design, engineering, in-house manufacturing, qualification, testing, and integration support. Our focuses are mainly space and aeronautics.
Very cool. Yeah, so you mentioned space. So obviously Compoxi does manufacturing for a few different industries, but what is their expertise in space?
So Compoxi right now has more than 800 products in orbit.
Very
Our
cool.
most common products are substrates for solar panels, but we have hundreds of them between LEO and GEO orbits. Compoxi also has expertise with manufacturing antenna horns for telecommunication satellites that are in GEO orbits and radomes for antenna coverings. One example is the ExoMars mission. We would also like to highlight our legacy in structural elements, such as the body of the Rashid rover that was made with composite materials, and our experience in the solar orbiter, that we have some structural elements there.
Those are some neat projects that y'all are working on. So before we get too far into more about what Compoxi does, could you take a second to explain what exactly a composite is for folks that might not be familiar with that?
So a composite is a combination of two or more materials together, where one material acts as a matrix. In modern composites, we call this is normally a resin. And the other one is normally a reinforcement material, which is the strong one. This combination gives unique properties that are superior to the materials on their own. So, for example, we can improve flexibility, strength, weight, conductivity, just by choosing the correct combination between the matrix and the reinforcement.
Very cool. Thanks. So what are some of the different processes that you use to actually manufacture these composites for space devices?
So Compoxi adapts to the customer needs. We normally offer a co-engineering service to help finding the best solution. We have several materials and manufacturing processes depending on the application. For the space industry, we mainly use hand layup pre-preg with autoclave and out of autoclave. This is our longest heritage. We also use resin infusion, and we have an automated fiber placement pre-preg robot that was recently qualified for space. We also have a wide range variety of fibers, resins, and core materials, so we can always adapt to the different applications that our customers might have. To produce all these highly engineered products, Compoxi holds an AS9100 certification. We also have a 1,600 square feet ISO 8 clean room in our manufacturing facility, which, by the way, we are expanding this year.
So what are some benefits to using composite structures versus kind of traditional metals that you would kind of associate with traditional spacecraft?
Well, there are many different benefits, but I would highlight mainly lightweight, high strength to weight ratio, good corrosion resistance, high impact strength, part consolidation, good thermal endurance, and dimensional stability, which is very important for in optical payloads, for example.
So that's a great list of benefits to using composite materials. I feel like that's applicable to an extremely wide range of different space applications. So that's super cool. What parts specifically can we use composite materials in spacecraft to replace traditional metals?
You can use composite materials in many different parts, but if we focus in carbon fiber reinforced laminates, these are the standard of the space industry, and you can find them in payload support structures, solar array structures, some struts, bus structures, rovers, as I mentioned before, with the Rashid rover, and satellite deployers. Then, if you use ceramic matrices, you can have high temperature special composites that can be used in the hottest parts of a spacecraft. For example, rocket nozzles.
Very cool. Yeah, I had no idea that you could do something like that with composites. What are some cool projects that Compoxi's working on right now?
So right now we are developing a deployer. We are trying to adapt to this fast-growing market that everyone is launching satellites, right? We also recently completed and successfully delivered the full composite body of the Rashid rover that was successfully launched by SpaceX and now is heading to the moon. This
Very
project
cool.
was very challenging in terms of complexity and execution time, but we succeed. And as for other projects, Compoxi is proud to have products and parts nearby three celestial bodies. We have parts in the solar orbiter that is heading to the sun, the Rashid rover that is going to the moon, and in ExoMars. Unfortunately, we are not there yet. So Compoxi is really looking forward into the reactivation of this program to proudly say that we are in Mars.
That's awesome. Yeah, speaking of future initiatives, would you like to talk about anything that Compoxi has their sights set on for future projects?
Yeah. Well, R&D has always been a strong business unit within the company. So our near future goal is to qualify our automated fiber placement arm to do 3D models. So now we can offer more customized products to our customers. But with the new trends of the space industry, especially in new space, Compoxi is putting a lot of effort and changing production technologies and manufacturing processes to be able to manufacture large volumes with a short period of time. Then, if we look long term, we would like to partner with any organizations or companies that would like to develop some or test some in-orbit manufacturing processes or disruptive materials, which all this, by the way, is the key for the future in the space exploration.
Absolutely, it sure is. Thanks for that great rundown on Compoxi. That's all super interesting, and yeah, I'm glad to hear that you found your way back into the space industry after doing the automation engineering. I'm sure you're having a great time working with Compoxi. Just to kind of to wrap up the conversation, talk a little bit about your experience with Nova Space. As someone who's actually lived it, going from a non-space industry engineering job back into the space industry, how was the Nova Space professional course a good tool for folks like you that are looking to get into the space manufacturing sector of space?
Well, as you know, Jeff, in the manufacturing industry, you have people coming from many different backgrounds, engineers, technicians, and they are really skilled employees. But if you are trying to optimize the final application for your customer, understanding the environment, in this case, the space environment, is the key to have success. So definitely the Nova Space course helped me to change this paradigm of manufacturing and going to specifically space manufacturing.
Awesome. Glad to hear it helped out a little bit in your career transition. So for people that might be wondering, why do I need to know about a wide range of topics in the space industry if I'm just focusing on something super specific like composites, for example? Why do you think having a more general knowledge of space is important for specialists?
So I would say it's beneficial in both ways, right? Any mechanical engineer with composites knowledge will have an added value when working for the space industry. Normally, traditional engineers in their degrees are used to design knowing the properties of metals. But composite materials are relatively new, and they can be a decision point, especially in projects where the weight can be a big constraint. On the other hand, as mentioned before, any expert of any field will optimize the design or the product if they understand the environment they are working on. So if that person has more knowledge about space, will produce and will succeed and will have better results. So overall, sharing knowledge across any industry allows for more innovation.
Yeah, I couldn't agree more. I mean, kind of having that general knowledge is what allows me, a history major, able to communicate with an engineer like yourself and at least sound like I know what I'm talking about, right? So yeah, that's a great point. Thanks for bringing that up. Well, that kind of is going to wrap it up for our live stream today. So Monica, thank you again so much for joining us again, and we're looking forward to having you on again in the future. You've always been a great guest for us. So yeah, keep doing great things out in Spain, and best of luck in your new job.
Definitely. Thank you very much, Jeff. And I'm really looking forward to participating in the next session.
All right. Thanks, Monica. Take care.
Bye.